Hi, I'm Professor Goins, and in this video I'm going to be discussing the concept and the procedure to find what are called critical points. Critical point on the graph is one of the following possibilities. So this point right here, this point right here, and this one over here has one right here. And why are those critical points? What's special about those, or what's different about those? If I look at these 2 points here, if I was to sketch in a tangent line, okay, that tangent line's horizontal. Same thing here, if I sketch in a tangent line, that tangent line is horizontal. If I look at this blue dot here, and I put in a tangent line, it's vertical. So critical points correspond to a point on the graph where the tangent line is either horizontal or vertical. And what do we know about horizontal tangent lines? Well, we know that the slope of the tangent line is 0. Over here, what do I know about the slope of a vertical line? The slope of this tangent line would be undefined. And we know to find slopes of tangent lines, we compute the derivative and plug in numbers, right? So that's how we get points, or slopes of those lines. So that means right here, in order to find where the slope is 0, we're going to solve the first derivative is equal to 0. So that's how I find horizontal tangent lines. I solve this equation. In order to find out when the slope is undefined, we're going to determine where the values of the first derivative is undefined. So there's really 2 steps to find a critical point, both involving the first derivative. Where is the derivative 0, or where is the derivative undefined? Let me give a definition again for the critical point. So conceptually, this is what they are, but just to add it a formal definition here. X equal to A is a critical point of f of x if f of x is continuous at x equal to a, and the first derivative at a is 0, or the first derivative at a is undefined. So there's 2 requirements. It must be a point on the graph at which the original function is continuous, and then one of the following 2 things has to happen. The derivative is 0 at that point, or the derivative is undefined at that point. Again, the conceptual idea is that so see this is continuous at all 3 of those blue dots, but I've got a horizontal tangent line here and a vertical tangent line here. Okay, let's go ahead and let's take a look at some examples of finding critical points. So for example, find the critical points. Okay, part A. Let's look at the function f of x is equal to 1/3 x cubed minus x squared minus 12x plus 7. Then for part B, let's look at the function f of x is equal to the cube root of x squared minus 9. And finally, for part C, let's find the critical points of the function f of x is x minus 4 log of x minus 1. Make sure that's on the screen there. Okay, yeah, we're good. All right, so find the critical points of those three functions. Let me see if I have how much space I have over here. Not too much. We could probably do part A over here. Okay, so solution for part A. All right, so first thing I have to do is I have to compute the derivative. So first derivative of this function here. See how far I can go over. All right, so we should be all right. Power rule, that gives me x squared minus 2x minus 12, and I'm going to set that equal to 0. So let me move it over here just to make sure it's on the screen. X squared minus 2x minus 12 equals 0. And it's a quadratic for which we have lots of techniques to solve. This one should factor nicely. So let's see, 6 and 2. Let me see if that's the same. Let me, actually, I want to make one adjustment. So we can certainly solve this one, and no, let's just leave it as is. So we're just finding the critical points. If this one doesn't factor nicely, I was going to go back and change this so that it did factor nicely, but it's fine. We can leave it as is. What I can do is, if I don't see how to factor it, then I can just use the quadratic formula. So quadratic formula, remember, is x is negative b plus or minus square root b squared minus 4ac all over 2a, where a, b, and c are the coefficients of a, b, and c. So if I plug those numbers in, negative 2 plus or minus the square root, b squared, so negative 2 squared minus 4 AC, so that's 1, and then negative 12. And I think that might be off camera. Let me write this up here and then I'll check. So let me see, I think that might be negative 12. Let me see if you can see that out there. I think you might be able to, but again, that's 4 AC. And then if I go ahead, let's shift it over here so hopefully we can see everything. That would be positive 2 plus or minus the square root of, so 4 plus 4 and 12 would be 48, all over 2. Let's clean this side of the board up. So that would be equal to, I've got 2 plus or minus the square root of 52 over 2. And 52 certainly is not a perfect square, but let's see, if I divide that by 2, you get 26. So I could divide that by 4, so this would be 2 plus or minus the square root. Again, it's even, so I can take out a factor of 2, so that's 2 and 26. 26 is even, so I can take out another factor of 2, so 2 plus or minus the square root of 2 times 2, which is 4 times 13 over 2. And 4 being a perfect square comes outside the radical, so 2 plus or minus 2 root 13 over 2. And then finally, I can cancel a factor. If I could factor it, I can factor a 2 out of the top, leaving 1 plus or minus the square root of 13. So this cubic polynomial has 2 critical points, 1 plus or minus root 13. Let's take a look at part B. All right, so looking at the function, the cube root of x squared minus 9. Now keep in mind, When we take a derivative of a radical function, what we want to do is we either write it or make sure we interpret it as an exponent with a rational number. So that'd be the 1/3 power of x squared minus 9. All right, so therefore the first derivative would be 1/3 x squared minus 9 to the negative 2/3. And since there's a composition, we need the chain rule, meaning a factor of 2x being the derivative of this quadratic comes out front. And then let's clean that up. So I've got 2x over 3 times x squared minus 9 to the positive 2/3. Okay. So there is the first derivative. And what we're going to do is use, let's see what I can erase here. All right, so we're going to use that and find the possible critical points. So I find the critical points. Remember that the critical points come in one of two varieties. Either the derivative is 0 or it's undefined. And in order for the derivative to be 0 in this case, that means that the numerator would have to be 0. In order for it to be undefined, the denominator would be 0. So really what I'll do is I'm going to set up two equations. So let's say I've got, so f prime equals 0, and then I'll also have, say, f prime is undefined. Okay, so for the derivative to be 0, that means the numerator would be 0, which gives me the equation 2x equals 0, and therefore x is equal to 0. So there's one critical point. The other thing I'm going to do is I'm going to set the denominator equal to 0. So notice what I can do is I can divide both sides by 3 and then take each side to the 3/2 power. That would give me the quadratic x squared minus 9 is 0. And if you remember your factorization formulas, this is the difference of perfect squares. And that would be x plus 3 is the first factor, x minus 3 would be the second factor. Product equal to 0 means one of the factors has to be 0. So I come up with these two simpler equations, giving me the values of x is negative 3 and positive 3. So those would be two more critical points. So I've got x equals 0 and then plus and minus 3 for the critical points of the original function that we used for part B. Okay. Finally, for part C, let me go back over here so I'm not squeezing it in on that side. So let's clean up the board over in this side. As a reminder, the function we were looking at in part C was x minus 4 natural log. A little too close there. X minus 1. So the first derivative, 1 minus, so I've got a constant multiple, so I've got a factor of 4. And remember, the derivative of a natural log is the reciprocal of the argument, so that x minus 1 goes to the denominator. And then bringing out from the chain rule, the derivative of x minus 1 becomes a factor, which we can put in the numerator, and of course the derivative of x minus 1 would be 1. And so then if I combine that, this would be 1 minus 4 over x minus 1. Of course, 1 is the same thing as x minus 1 over x minus 1. And then I can subtract the numerators there, which would give me x minus 3 I would have x minus 1 minus 4, so x minus 3 over x minus 1. So there's my first derivative. And I'm going to use that again to find where the critical points are. Okay? And just like we did in the previous one, let's kind of separate this into the two possibilities where the derivative is 0 or the derivative is undefined. All right, so I've got f prime equal to 0, and I've got f prime undefined. Just like before, what we'll do is we'll set for the derivative equal to 0, I will set the numerator equal to 0, and for the derivative being undefined, we'll set the denominator equal to 0, just like we did before. For this one, of course, these are super simple to solve. I just add 3 to the other side, so I get x is equal to 3. Over here, I get x is equal to 1. So, a couple of comments. 1, 3 is definitely a critical point because when I plug that in, the derivative is equal to 0. And on the surface of it, it looks like 1 would be a critical point because when I plug 1 into this, it's undefined, just like it was in the previous example, which we claimed to be we stated these as critical points. The problem here, if you remember back to the definition, the function has to be continuous and of course defined at that x value. X equal to 1 is not in the domain of the original function. So this is actually not a critical point. So not a critical point, whereas this one over here is. So this function does only have one critical point. So make sure when you're finding your critical points, you double check your answers at the very end to see if they're actually defined in the original function, because you might get some answers incorrect if you just come to the end and you don't check those.